approaching cars were caught head-on collision on a vertical summit curve connecting 4% ascending gradient with 3.5 descending gradient. So we have a case 4% gradient, that this with 3.5% gradient, and this is a vertical summit curve, right? So let us draw a vertical summit curve like this. So this is n1 is equals to 4%, and this is n2 is equals to minus 3.5%. So minus 3.5% is descending gradient. So in this case, if you project this and determine this angle is deviation angle. So that will be n1 minus minus n2. So that will be n1 plus n2. So the 7.5% will be the deviation angle in this case. So what we have been said is that the posted speed on this road. So suppose that there is a speed that have been posted as 70 km/h in this road section in this vertical curve, and the highway engineer checked the geometrics of the road and found that the highest point on the curve lies at a distance of 120 meters from the beginning of the vertical curve. So you have, let's suppose this is the beginning of this vertical curve, and suppose that this is end of the vertical curve. So the beginning of the vertical curve and the highest point on the vertical curve is led with this. So it have been said that in the vertical curve is 120 meter from the beginning of vertical curve, that this we suppose end of vertical curve. So we have been presented the distance x is equals to 120 meter, right? So check if the crash is due to fault in the posted speed sign. So now you have to check whether 70 kmph provided posted sign is the cause of the crash in this type of vertical curve. You have to use the height of driver's eye, suppose h1 as 1.08 meter. This is height of driver's eye. So you have a driver negotiating this vertical curve, another driver negotiating this vertical curve. So the height have been given of the driver's eye as 1.08 meter. So you can also write the height of the another driver approaching this road section as 1.08 meter. So also you have been presented that reaction time or perception time of the driver in this case as 2.5 seconds. So the coefficient of longitudinal friction of this vertical curve is given as to be 0.35. So you have to find what should be the posted speed if there is fault in this speed limit sign. So if 70 kmph is the real cause of the accident or not, if it is, you have to find what is the adapted or new speed that should be provided in this type of vertical curve. So this is the question, and let's see how you can do this. So this is our case. Now we know that the highest point on the curve from BBC is given by the formula n1 times r, and also we know that the length of this vertical curve is equals to n times r. Then r can be replaced by L by n. So this equation x is equals to n1 means 4 by 100, and the value of radius of this curve is L by n. So if you solve this and put the value of x as 120 meter, 4L by 100, it is n. Then in the case of n, what you need to provide is n is the deviation angle, and it is nothing but 7.5%. So then that will be 7.5 divided by 100. So solve this, you will find the value of length of this vertical curve using the geometry and the highest point on the curve as 225 meter, because the distance of this or the location of the highest point in this curve from the beginning of vertical curve is found to be 120 meters. So this is the length of the vertical curve in this case. So after determining the length of the vertical curve, then what you need to check is that whether this length is sufficient or not, right? So actual length of this vertical curve in this case is 225 meter. Then what you have to find is, look, so this is the one car, this is another car, these are approaching each other in this curve. Then you can find the stopping side distance, right? Stopping side distance in this case when these two cars are approaching each other, right? So stopping side distance when these two cars are approaching each other, right? So that can be easily found by the formula. Stopping side distance is the stopping distance of first car plus stopping distance of the second car, right? So stopping distance, stopping side distance from the first car, if it is approaching in this 4% curve, is given as 0.278 v into t plus v square by 254 f plus, since it is ascending, so n1, right? So this is for first car, and if you add for the second car, so same formula can be written like this, right? So 254 f plus it is n2. So this is for second car, right? So if you put the value of t as 2.5 seconds and the value of v as 70 kmph, that is the posted sign, then the stopping side distance of this first car will be coming out to be 98.155, 115 plus, if you solve this it will be coming out to be 98.7 meter. So the value will be coming out to be 196.872 meter. So the stopping side distance in this case will be coming out to be 196.872 meter. Now this is the value of s, right? This is the stopping side distance, right? So whether this is sufficient or not, so how you can do is, length of this vertical summit curve is greater than side distance or not, we'll be applying this case at first. Then we'll be checking L is what. So what is the value of L if length of this curve is greater than stopping side distance? Since you all know that stopping side distance is the condition where the length of the summit curve is designed for. So whether length is greater than S, we first assume this. Here we assume this. So this is the actual value of length of the curve provided in this case. So this is the actual value. So this is the actual value that is provided is 225 meter, right? Now using the stopping side distance in this case, we will be checking whether what is the value of L if the length is greater than side distance, this that we are trying to assume. So for that, what you can do is, length is greater than stopping side distance, then the formula is ns square divided by 2 root h1 plus 2 root h2. So you have to whole square this. So implies that L, so n is deviation angle, so that is 7.5 percentage, 0.075. Side distance is nothing but that you have obtained stopping side distance 872, right? So that is square. So now what you have to put is 2 into, so h1 is 1.08 meter plus 2 into 1.08 meter. So you have to whole square it. Then you can easily find what is the length of this vertical curve, assuming that the stopping side distance is this. So for this case, if you assume 70 kmph speed, then you achieve the stopping side distance as 196 meter. Then the length of this vertical curve required is 336.446 meter. Now say, so length of this vertical required is 336.446 meter. So if you provide 70 kmph speed in this vertical curve, the length required is 336 meter, right? So length of the vertical curve for 70 kmph should be 336, but the highway engineer has found the length as 225 meters. So what you can say is that 70 kmph speed limit has caused the crash, and the highway engineer found the crash is because of the 70 kmph speed. So since L actual is less than L, that is L because of 70 kmph, right? Then you can say that there is a crash due to fault in posted speed. Yes, this is the actual cause of the accident because of this 70 kmph speed limit, right? So what you can do is now you have to find, you have to use, so this is the actual length. So for this actual length, what is the speed for this curve? So what you have to find is that stopping side distance, right? You have to find the stopping side distance first, right, for this case, then you can proceed to next. So what you can do is, so now you assume again length of the curve is greater than side distance, right? So you assume this L is given as ns square by, so that will be formula 2 root h1 plus 2 root h2. So this is the whole square part. So you can do this, right? So what is the length of this curve? So the length of the curve actual is 225 meter. So n is 0.075, s is square. So you do this 2.108 plus 2 into 1.08. So this is will be the square part, right? So solve this and you will find the value of stopping side distance as 160.997 meter. So the stopping side distance in this case will be obtained as 160.997 meters. So this is the case obtained when the length of this curve is 225 meter. So that is the actual case. So the length corresponding to 225 meter, the stopping side distance is found to be 160.0. For this stopping side distance, now you have to determine the posted speed, right? The actual speed that is to be provided in this vertical curve, right? So the actual speed that is to be provided in this type of vertical curve is to be found for this stopping side distance condition and for this length of the curve, since it is the actual length that is in this case that have been provided, and that is the cause of the failure. That is the cause of the failure, since length should be more for 70 kmph, but the provided is only 225 meter, right? Stopping side distance will be the stopping side distance of first car and stopping side distance of the second car. Then stopping side distance is 160.997 meter. What is the stopping side distance of first car? That will be 0.278 v into t plus v square divided by 254 f plus 0.040 is the gradient, since they are ascending each other. So that will be first case of first, right? So another will be 0.278 v into t plus b square by 254 f plus 0.035. So that will be of second case. Now you can see that this is second case. Now the reaction time of the driver in this case is 2.5, and everything here is given. Since t is 2.5, t is 2.5, right? So you can just put the value and you can get the equation, right? The equation will be coming out to be, so I can write here 160.997, that will be equivalent to 0.0 0.020 v square plus 1.390 v, right? So that will be a sort of equation. So this equation, v square plus 1.390 v minus 160.997 is equals to 0. So this is quadratic equation in v, and if you solve this, the value of v will be coming out to be 2. The negative value is to be discarded and only the positive value is taken. So you have got two values. So one of the value of design speed is 60.465 kmph, because so in this condition, so one of the value of design speed is coming out to be 61.465. So what you have found is that the posted speed has caused the accident in this case. Now the posted speed is to be changed and is to be adopted as 61.465 kmph, as the length of this curve is 225 meter for this 160.997 meter stopping side distance. So now you can say that the posted speed may be changed to 60 kmph in this case, so as to avoid the crash in this case.